Assalamu alaikum everyone. Dear student, you are welcome in the first experiment of the 8th semester of practical organic chemistry for the third stage. We'll start this semester with the preparation of diazonium salts experiment. This experiment is very important because diazonium salt as intermediate used in many experiments and many reactions for preparation some another intermediates and products we can use like in Saint-Meyer reaction or to prepare as a compounds. And also this experiment we can use it to distinguish between the primary, secondary and the tertiary amines. This reaction could include the nitrization of amine by nitrous acid HNO2. The nitrous acid is generated in situ, which means prepared and used in the solution from the reaction between sodium nitrite and any strong acid like hydrochloric acid or sulfuric acid to produce diazonium salt. So this is the structure, the general structure of diazonium salts. So the starting material is amine, and the reagent we will use called nitrous acid. At the beginning, let's explain how we prepare and use nitrous acid, and we talk about some properties of this acid. Nitrous acid is a weak acid and only known in solution because it's unstable, so we have to prepare nitrous acid and use it in the solution. The structure of nitrous acid is HONO, produced from the reaction between sodium nitrate in the presence of hydrochloric acid. Hydrochloric acid will protonate the sodium nitrate to give nitrous acid. As I said, nitrous acid is unstable, so with excess of HCl in the acidic medium will complete by protonation by using HCl and losing H2O molecule to give us nitrosonium ion. With the electrophile we will use it to produce diazonium salt, like we'll see in the mechanism which shown in this paragraph. So the formation of diazonium salt from primary aromatic amines, this mechanism called diazotization, formation of diazonium salt. First part by the attacking n-share pair of the nitrogen on the aniline on the electrophile to produce from nitrous acid decomposition to produce and to formation N-nitrosoamine. Now look at this step. It's very important step and I will explain in the next mechanism. Don't forget, here we have two hydrogen atoms. Now next step, from the N-nitrosoamine we'll lose H2O to form diazonium salt. by proton transfer steps like this tautomerism between the intermediate to give hydroxy substitution. And also this hydroxy and is present in the acidic medium from hydrochloride. So at this step, this hydroxide will be protonated by HCl to give us OH2 plus, which is good leaving group. After losing of H2O molecule, we will get the diazonium salt, and there is a tautomerism between the unshared pair and the positive charge to be like this diazonium salts. And of course the Cl we called the counter ion. If you use HCl, so we'll get Cl minus, but if you use sulfuric acid, we'll get OSO3 minus. Now this is the mechanism of formation diazonium salt from primary aromatic amine. But if we use the aliphatic or primary aliphatic amine, so the mechanism will repeat again with the same steps, but look at the final step. The diazonium cation, since there is no unshare or there is no sharing the positive charge with the aromatic ring, because there is no aromatic ring in the aliphatic amines like in the aromatic amines, so the diazonium salt which produce from the primary aliphatic amine will lose N2 as a gas, nitrogen gas, to produce carbocations intermediate, which then convert to alcohols or alkenes or another final product, not diazonium salt. So the intermediate resulting from the diazotization of primary aliphatic amine are unstable, so they are rapidly converted into carbocation after losing of nitrogen, and yield products derived from substitution, elimination, or rearrangement process maybe produce a primary carbocation. So if there is a chance to convert to secondary carbocation or to tertiary carbocation, all these intermediate will give different final product. So the mechanism until here is the same mechanism with the primary aromatic amine, but in aliphatic amine there is no ring to share the or to locate it, the positive charge with conjugated double bonds, so we're losing nitrogen as a gas and produce carbocation, and the carbocation will give another final products. Now let's see what happens if we use another type of amine. If you use secondary amines, so we will get N-nitrozoamine, not diazonium salt, because look at the mechanism of the reaction. Look again at the mechanism of the reaction. After producing N-nitrozoamine, this oxygen will protonated by HCl, and this hydrogen will abstract by a molecule of H2O. As I said, there are two hydrogens here, but in on the secondary amine there is one hydrogen, so we will lose it at the first step, and then the second step there is no more hydrogen, so the reaction will stop here, produce N-nitrosoamine. In the tertiary amine there is no any hydrogen here, so with the reaction with H1O2 or any acid you will get the ammonium ion. Even the N-nitrosoamine will not produce. So the diazonium salt prepared from the primary aromatic amine with nitrous acid. And also we can get from primary aliphatic amine, but this product is unstable because convert it to the carbocation to give another product, and the secondary amine will get N-nitrosoamine, and with the tertiary amine you will get ammonium ions. The diazonium salt are very important compound, as I said, and can undergo different type of the reaction. First common reaction with the diazonium salt is preparation of azo compounds, and also the azo compounds is very important product we can use in different fields by using coupling reaction. So we have here a starting material, diazonium salt. After preparation in the first step, this diazonium salt react with aryl of compounds, and in this compound should be have or substituted by good or strong donating group. By located this N-share pair on the oxygen, because it's conjugated with the aromatic ring with the double bonds here, and then will attack the nitrogen of diazonium salt. After this conjugated double bonds, you will get this intermediate. Of course here there is a hydrogen, so this hydrogen will abstract by the counter ion, and this bond will equal the positive charge on the oxygen by located the double bond in this way. After that you will get Cl with H to produce HCl, and the final product is azo compounds. As I said, azo compounds have different uses in the reaction and in industrial field. Another type of the reaction which diazonium salt can undergo is the substitution reaction by replacement of N2 by any atom or a group of atoms. The famous or most common reaction in this type we call Sandmeyer reaction to produce aryl halide derivatives from diazonium salt. If you need fluorobenzene, you can use NaPF4 with the diazonium salt to get fluorobenzene, and also with the chlorobenzene, bromobenzene, iodobenzene, and cyanobenzene. And you just need addition of H2O and rising the temperature of the diazonium salt, you will get a phenol, because diazonium salt decompose if the temperature is right. So in this experiment, all the conditions should be in ice to minimize the chance of dissociating of diazonium salt. Now, let's move to your handbook and explain some point in this handbook. As we said, the product of this reaction, preparation of diazonium salt, depend on the type of amine, whether it is a primary, secondary, or tertiary, whether it is aliphatic or aromatic amine. As we see in the mechanism, the secondary amines, either aromatic or aliphatic, will give N-nitroso compounds, like this example of reaction between piperidine and nitrous acid will give N-nitroso piperidine. And the mechanism we just saw with the mechanism of the secondary amines. Here also the secondary amine will give N-nitroso N-methyl aniline, this nitroso. With the tertiary amine, because there is no any hydrogen on the nitrogen, and if this tertiary amine is aromatic, so there is a chance to get electrophile attack on the aromatic ring at the para position, like this product 4-nitroso nitrogen methyl aniline. And of course the primary amine react with nitrous acid and produce diazonium salt, but this diazonium salt is very unstable. We will get different produced like alcohol, primary or secondary, depending on the carbocation produced, and maybe it's by elimination we will get some olefins and other compounds. So from all these reactions, the most important one is the reaction between primary aromatic amine with nitrous acid, which forms the more stable diazonium salt. And this salt is stable below 5 Celsius. So this salt will decompose to phenol if the temperature rises. So during the experiment, we have to achieve our additions, our work up with the ice bath. Here's some notes we have to focus on it. Diazonium salt are explosive compounds when they are dry, so they are prepared and used in the solution. Since diazonium salt is unstable and contains N2, so this N2 is a good living group, so avoid draining the diazonium salt solution or mixture. The diazonium salt should be always in the solution to prevent the explosion of this compound. So be careful at the experiment. you have to take care during the stirring or during the hand work by this salt, because this salt are explosive compound if they are dry. Then diazonium salt also decompose when the temperature is rise. So we have to achieve again ice in the ice bath. Other compounds which we'll prepare in the first week are insoluble compound in water. Now let's move to the procedure. Part 1. You need a conical flask. In this conical, put 4 ml concentrated HCl with 10 ml of water. 4 ml of HCl, 10 ml of water, and 2.5 ml of aniline. Then shake this mixture until the aniline is dissolved in the solution. Then cool the mixture under 5 Celsius by using ice bath. To this solution, add another solution of NaNO2 sodium nitrate, which dissolve in 10 ml of H2O. So here you have 2 solutions. Solution number 1, 4 ml HCl, 10 ml of water, 2.5 ml of aniline. And the solution number 2, you have 2 grams of sodium nitrate with 10 ml of H2O. So add solution number 2 to solution number 1 and slowly, and be sure that the temperature is between 5 or below 5, because any rising of temperature will lead to dissociation of diazonium salt. After the addition with the stirring, then prepare another solution from the part 2. From the part 2, in a beaker, take 0.1 gram of beta-naphthol and 2 ml of 10% of NaOH of solution. Also cool this mixture below 5 Celsius. Now you have another solution of beta-naphthol with NaOH solution, and you have this solution by addition HCl, water, aniline, NaNO2 with another amount of H2O. Shake this solution, and to this solution add 10 ml of diazonium salt solution slowly. The product will be red solid. After completing the addition of diazonium salt, you have to filtrate the solution by Buchner and then dry it and calculate the yield. Again, this experiment had in the first week 2 parts. Part 1, preparation of diazonium salt, and then reaction of diazonium salt with the beta-naphthol solution to prepare as a compound as a red solid product. In the part 2, or in the week number 2, you have to prepare diazonium salt with the same procedure of part 1, and then prepare from the diazonium salt, prepare the phenol. Now the procedure, repeat part 1 and then start with part 3. So prepare a diazonium salt as shown in the procedure, the part number 1, and then start heating after you finish the addition. start heating the diazonium salt, which is unstable if the temperature rises. So the nitrogen will evolve and the salt will dissociate. And be careful, do this part in the hood. After the evolution of nitrogen, you have to take this product as impure phenol by using distillation to get the pure distilled material. After distillation, extract the phenol by using ether, and then dry the ether solution by some of grams of MgSO4. And if you need to distill the ether again, if there is maybe some molecule of water, now distill the products or the mixture to get distilled phenol. Take care, phenol is a skin-bearing substance, so you have to take care in this part. After you get the phenol, weight it and calculate the yield. And don't forget the phenol melt at 43 Celsius. So you have to check out the weather at that time of the experiment or at that day of the experiment. Again, preparation of phenol from diazonium salt. You have to prepare diazonium salt like in part 1, and then just by heating the beaker of diazonium salt in the hood, nitrogen will evolve to losing N2 and producing phenol. This phenol is impure. We have to distill it, and then we have to extract it by ether, then dry it by MgSO4, distill it again, and weigh the phenol and calculate the yield. This is the part 3 for the week number 2. I hope that's clear for you. This is very important experiment. Will give you some deep information about the behaviors of amines, different types of amine, primary, secondary, tertiary, aliphatic or aromatic, and you will use it many times at the next year with the 4th stage, inshallah. So it's very important experiment, because you will get some information about amines, and also you will learn some technically procedure. It's very easy, but you have to be careful with the dangerous materials. So I hope you will save in this experiment. I will see you in the lab, inshallah. Please read the procedures, the principles, watch the video, read the PowerPoint and the handbook, and if you have any questions, I will be happy to answer you at the lab. See you soon. Bye bye.